for various applications, and this is just connected simply with 2 hoses. Most of you are going to receive a Motorcraft FG15 fuel filter. And the key here is that as you install this filter, you do not, repeat, do not use Teflon tape on the threads, but you must use this little triangular gasket that slips over the fuel filter, and the gasket is what keeps the threads and the fuel from leaking. We will now install this filter into the carburetor, and it just gently threads in. There is not a great deal of pressure that is required. Again, no 4-foot cheater bars. And we're going to reattach our rubber line that we had used earlier. And that will work just wonderfully. Many of you will be, instead of using a rubber hose, which we really don't recommend too much length of, many of you will be using a correct factory fuel line, such as this one for a 66 application, that there would then be a short piece of rubber hose, and it's a solid steel connection between the fuel pump and near the carburetor, where the short piece of gas line would make the connection. Other applications will have a direct piped fuel line, and I will take the little cover off of these threads, and the 1/2" 20 threads, which is what these are, screw directly into the carburetor, or sometimes in an earlier application into a brass adapter fitting at the front of the carburetor. If you are in a situation of using this threaded fitting, you are going to be required to use a small amount of Teflon tape. Now, there's only one trick to using Teflon tape, and that is that you must not get it over the first thread. If you do, and this is a very common problem, if you get it over the end of the first thread, it will flake off and it will get caught in the needle and seat of the carburetor, and you will have, again, what we call Old Faithful, and this will happen about after 15 seconds of operation. And you're going to call and be very upset, saying we shipped you a defective carburetor. Don't put the Teflon tape over the end of the threads. The next item that we are going to address is reinstallation of the throttle rod. This correct throttle rod for a 289-302 is what I am holding. And the little clip that we're showing you a close-up of is still available brand new today. And this small clip will hold the throttle rod in the correct hole. I am holding in my hands a couple of examples of throttle shaft arms. Notice one has a linkage ball on it, one doesn't. And there is even a third type, which is really the most correct for the mid-60 small blocks. We see so many vehicles at car shows that have had the linkage rod installed in the top hole. This is absolutely incorrect. The linkage rod needs to be installed in the next hole down and the one closest to the rear if you have this type of a throttle shaft. If it's installed in the top hole, you will never get the throttle plates wide open, and you'll wonder where all your horsepower went. The fulcrum changes from the pivot point, and you have an absolute definite problem. Just about the last thing that we have to do in getting this carburetor properly mounted is to put the hold down nuts on. I'm holding in my hand NOS correct original pieces that are 7/16 wrench size. These are not available from your hardware store. We do carry them. They're not plentiful, but we do have some. And we're going to put these right on the carburetor. And keep this thing from flying off. As you install these nuts, you do not have to tighten these down particularly tight. I've got my 7/16 inch wrench. Sometimes if you're wanting to be more efficient, you can use a socket, but I'm only using a couple of fingers of pressure on this, and you can see I'm just pulling it gently snug. So many folks want to use a 4-foot cheater bar in the installation of these hold down nuts, and you warp the base, or worse yet, crack it, and the carburetor pretty much becomes unusable at that point. We're now ready to double check all of our connections to make sure that we've not left anything undone. I've got fuel line, distributor, choke tube. Fuel line obviously is the one that's most important. Carburetor's been mounted and the hold down nuts have been secured, and we're ready to crank it. Now the obvious thing everybody wants to do at this point is move the throttle a whole bunch to get this thing to start. Well, there's no gasoline in it, so it's not going to make any difference whether you move the accelerator pump or the throttle or not. So we're just going to crank the engine over for about 5 or 6 seconds, let fuel build up, then we'll move the throttle and you'll see what happens. Now we are going to move the throttle 5 or 6 times, and because there's now fuel in the float bowl, by energizing the accelerator pump, we can now pump some fuel into the engine. Now listen. We are going to let this run for a few minutes and allow the choke tube and all of those things to work. Going to double check it for leaks, and once the engine gets to operating temperature, we'll be ready to make our adjustments to get this carburetor totally dialed in to the particular application. One brief comment concerning a throttle return spring and bracket on many of the mid-60s small blocks. This is a correct bracket for the throttle return, and it goes as per our close-up here. We'll go above the carburetor but below the nut on the driver's side rear toe of the carburetor, and the spring hooks around the offset in the throttle rod, with the other hole going in the small hole in the bracket, and the bracket generally is pointed at your driver's headlight. One piece that we didn't show you earlier was a correct pre-bent PCV, positive crankcase ventilation hose, that attaches to the rear of the spacer plate and with no clamp, and then the other end of the hose will go over to the passenger valve cover and go over the PCV valve. The engine's been running for several minutes now, and you will notice that the choke plate is vertical, straight up and down. The choke cap is very warm. I'm now going to slow the engine down a little bit. And notice that the carburetor is running approximately the correct speeds. And that's because it was factory run here in our test room before being shipped, in this case reinstalled on our test engine. We are now going to share with you the most important piece of information that you probably will hear all year long, and that is regarding ignition timing. 99% of the clients that do have a problem have not followed our timing procedures. They have used a timing light to set the ignition timing. Timing lights categorically do not work. I repeat, timing lights do not work. The problem is not the device, meaning the timing light. The problem is harmonic balancers. I'm going to shut this engine off so you can hear me a little more clearly. Timing lights in and of themselves are a wonderful device. The number one problem in the classic car industry is the movement of harmonic balancers. Harmonic balancers are made up of three parts: an inner steel ring, an isolation rubber ring, and the outer ring. Your timing marks are located on the outer ring, and the harmonic balancer outer ring moves. So people every day call us and they say, I've got my timing at 12 degrees and it's dead perfect. It's not perfect. Even brand new harmonic balancers are not made properly. You will listen to this if you'd like your car to run properly. You will not use a timing light to set your timing. Sounds like I'm serious, I hope. Let's tell you how to do this, and this method is absolutely goof-proof. We're going to give you some visual reference points. To my right is where your firewall would be. We're going to call the firewall 12 o'clock. To my left, where you can see where the radiator is, we're going to call that 6 o'clock. No matter what engine that you have manufactured by Ford Motor Company, as long as the distributor is mounted in the front, the center line of the distributor vacuum advance unit, and the vacuum advance unit is this guy right here, and the center line, whether it be with a steel line or a vacuum nipple, the center line will point at 7 o'clock, meaning at your left pocket. If you are standing at the radiator looking back at the engine, the center line of the distributor vacuum advance unit will point at your left pocket if your distributor has been installed in the proper tooth. I want to say that again. If your distributor has been installed in the proper tooth, that's a key word here. If you're a tooth off, which most of them are, your vacuum advance unit is going to hit the thermostat housing and your timing will still be late. Here's how to set your timing now. You are going to rotate the distributor to where the engine idles the fastest. We gave you the reference points if your distributor's been installed in the right tooth. Let us now demonstrate. The timing on our test engine here is already very, very close. Listen to what happens when I retard the ignition timing. Hear the engine start to labor and slow down. We'll also show you a close-up of the vacuum gauge, that the vacuum has dropped. Watch what happens at the vacuum gauge when I speed the engine back up as far as rotating the distributor to where the engine idles the fast. Watch the vacuum again. I'll do this again. I'm going to retard the timing. For late timing, advance the timing to where the engine must run. Where your engine idles the fastest is where you must set your ignition timing. Never ever retard the timing on an engine. You must follow this procedure, but only if you want your car to run like it's capable of. Once you have set the timing by our method, after all of the other adjustments have been made to the carburetor, any of those that were required, and many of you will require no adjustments whatsoever, take the car out and drive it. If on hard acceleration at operating temperature, if the engine pings, back off the timing the slightest bit. If you have to back off the timing a great deal from where we have instructed you to set it so that the engine won't ping, then your distributor curve, in other words, the distributor advance curve, is way out of whack, and you must get your distributor recurved. We've now got our ignition timing set, and you will again will notice that our distributor is the vacuum advance unit, the center line of it is pointed at 7 o'clock. Be very careful in doing this so you don't lose any fingers. I've reconnected the vacuum line. We're now ready to make some tweaking adjustments on the carburetor. This is where a tach dwell meter will help a great deal. In neutral, I want neutral or park, I want the engine idle speed to be about 700, which is our gauge. You have to read it by half, but we'll show you a close-up here. We're at about 750 RPMs. I'll back it down to about 700 to get it approximately correct. We're at operating temperature. We are now going to adjust the idle mixture screws, and we'll bring you into a close-up here of the idle mixture screws. The idle mixture screws are located at the bottom front of the carburetor, and both of these control fuel or gasoline, but only gasoline discharged at idle. I'm going to pick one of these screws. It makes no difference which one. And as I rotate it in clockwise, I'm going to shut down the amount of fuel being discharged at idle, or lean it out. Hear how the engine has started to slow down. It says, I don't like that. So we're going to back that back out. To where the engine idles the fastest. We're going to go to the other side and do the same, excuse me, we're going to go to the other side and do the same thing to back the idle mixture screw in or out to where the engine idles the fastest, and also where the intake manifold vacuum is the highest for those of you using a vacuum gauge. There are other choke adjustments that we are not going to talk about at this point in time. These have been set at the factory. Here, we will talk about one of the choke adjustments, however, and that is the choke and loader nut. By the way, notice, look at the nice spring tension on this choke as that bimetal spring in the black choke cap is warmed up. If you notice when you first started your engine that the choke plate opened immediately just a little bit less than 1/8 of an inch. If your engine starts and dies and there is no black smoke coming out the exhaust, this choke and loader nut, in this case on our carburetor that we have installed, is a 64.5, early 65 brass nut, but most applications will have a nylon nut that is called a choke swivel, and as you rotate that counterclockwise, you will lean out the choke and loader adjustment, and as you turn that clockwise with a 1/4 inch nut driver or 1/4 inch socket, you will richen the mixture. And should the engine start and die with no black smoke, you would want to turn that either brass or nylon nut clockwise. If it starts initially and there is black smoke, you would want to rotate the brass or nylon nut counterclockwise. Most of you at this point may not even care or need to view the rest of the video. We do go through identification, going from a 2-barrel to a 4-barrel, and troubleshooting and problem solving. But thanks for your support. Thanks for buying our product. Go out and enjoy your car. It'll run better than it ever has since it left the factory brand new. And if we can ever be of help, please do feel free to call us. We're going to cover some brief identification of 4100s. For those of you that thought they were all alike, take a look at this table. There are many different versions, and we'll start with the very first one. Autolite first introduced the Autolite 4100 in 1957. You will notice right behind the rod on the driver's side, the characters ECZ, every Charlie Zebra. We're zooming in to show you a close-up of this. Notice the extraordinarily long accelerator pump sticks out almost 2 inches. And this is the first year of the Autolite 4100. The next version shows an EDC, Every Dog Charlie. It can also be an Every Dog Tom, or EDT. This is 58. This particular core doesn't have the right choke plate or the right lid. Typical mass rebuilder that doesn't have the right pieces. Late 58, but mostly in 59, Ford went to a different parts numbering system, and right to your right, my left of my index finger are some tiny numbers, and this one reads 575-2309, 59 only. And again, right behind the accelerator pump rod, and in this case just below it, you'll see the numerals 1.12. That's the Venturi diameter, meaning that the hourglass shape is 1 1200ths. Also notice that this has what we call the long snout. Another close-up of the 58 and 59. You will notice that the choke plate has a little flapper in it. This is the choke unloader device. Again, unique to 58 and 59 only. (1960) is the first year of the engineering number stamped in the driver's side front toe. Again, just left of my finger down on the mounting flange. You'll also notice behind the accelerator pump rod the 1.12 designation again. Notice for 1960 and 61 only, again unique to those years, another change in the choke design, which again didn't work. You notice a series of holes drilled. That is for 60 and 61 only. All of the carburetors that we have shown you at this point are what we call a long snout or long accelerator pump design. Note the big screw in the top of the accelerator pump housing and how far that the housing sticks out from the main body. Note the later design, and we'll put them side by side so that you can clearly see the difference. The bottom carburetor, as you are looking at them, is the short accelerator pump design or short snout. This took place in mid-1964 and was a major engineering change. Also, all of the 1.08 Venturis are short snout or short accelerator pump design. In addition, all of the choke housings on the short accelerator pump design or short snout have a choke piston and are of a better design. Most all of the long snouts do not have a choke piston, and the chokes do not work nearly as well. We've talked so far about the Venturi size of 1.12. We're now going to talk about the 1.08 Venturi, which is the correct factory size for all of the 289s except 289 hypos. The 1.08 Venturi was also used on 66 Galaxy and Thunderbird 390s and 428s. Yes, 66 428s had a 108 Venturi carburetor unless it was a true police interceptor. The 108 Venturi carburetor was rated at 480 CFM, and the 112 was rated at 600 CFM. Please note, and we'll show you these again side by side, the thick walls around the throttle plates versus the thin walls around the throttle plates. The one in my left hand or to your right is 480 CFM. The one on the right, which is the 112, is 600 CFM. It's easy to understand why, because the holes are bigger. And the bigger the holes, the more stuff you can get through them. Stuff in this case meaning the correct air-fuel mixture. There were about 10 112s made for every one 108. And when Pony Carburetors first started business, you could get 108s and 112s, and they were all a dime a dozen. Through the success of the device that we started with, which happens to be the best carburetor on the planet, and what articles have been written up, the 1.08 Venturi carburetors have become almost impossible to find, and we have come up with